Okay, so we saw the binomial square. If you took a plus b squared, it expands into the first term squared plus twice the product of those terms plus the second term squared. Now, often you'll see a second pattern for the difference of terms in that binomial. It's not necessary. If you just think of this first term as being a plus a negative b, you'd get the first term squared. You take the product of the terms as a times a negative b is negative ab. Double that, you get negative 2ab. And then if you take negative b and square it, it still becomes a positive b squared. So you can write two separate forms if you want to, but there's no reason to. The signs will take care of themselves even if you just leave them. All right, so let's take a look at a few examples. Okay, so if we took this binomial square and we apply our pattern that we know, okay, the pattern is that we will take the first term and square it. So 5 squared is 25x squared. Then we take the product of these terms and double that. So 5x times a 3 is 15x. Double that, you get 30x. And then we take our last term and square it to complete our pattern. 3 squared is 9, and that gives you the expanded form of that binomial square. Okay, so try this one on your own. Once again, you should be able to work pretty quickly with mental calculations on this. Okay, can you expand out 3x minus 2 quantity squared? All right, so if we take our first term and square it, 3 squared x squared. Take the product of our terms and double it. 3x times a negative 2 is negative 6x. Again, notice the sign will take care of itself. Double negative 6x, you get negative 12x. And then square our last term. Our last term was a negative 2. Negative 2 squared, b plus 4. Questions on that? All right, try one more like this, and then I'll give you a little more challenging one. Right, recognize you have a binomial square, so it fits the pattern of square the first term, square 5 square x. Then it's plus the double the product of the terms. 5x times a negative 7 is negative 35x. Double that, you get negative 70x. And your last term is the last term squared. Negative 7 squared is plus 49, and that would be your solution. All right, what I would like you to do is see if you can expand this binomial square, or this product. Quantity x plus y, all plus 2, the entire quantity squared. Were you guys able to use the binomial square pattern, or did you just write it out and distribute it? Okay, I'm going to go through both methods. If you can use the binomial square method, this might save you a little bit of time. Okay. Here, if you recognize that this again fits the pattern of a plus b quantity squared, where a is that whole binomial. Okay. When we expand this out, we take the first term and square it, so we're going to take x plus y squared, plus twice the product of the terms, so we have 2 times the product of the terms, which is 2 times x plus y, and then plus our last term squared, which is 2 squared, or 4. So if we expand this out again, we have another binomial square here. So we square the first term, x squared, double the product of the terms, x times y doubled is 2xy, square the last term, y squared. We have 2 times 2, which is 4. We're going to distribute that through. We get 4x and 4y, and then our constant 4. Now, as far as rewriting these in standard form, your top priority is degree. So our second degree terms are first, then our first degree terms, and then our constant. So they're in order from degree. So the second priority is alphabetical order. So only x's first, x's with y second, only y's third, and then again x's and y's in the order that we see the remaining terms. Okay, so that would be our completely expanded expression. All right, now let's assume that you would prefer to just distribute. Okay, would that make any difference? So instead of saying x plus y plus 2 squared, if you just wrote it out as being multiplied by itself and then distribute, here with our first term we get x squared plus xy plus 2x. Move to the next term, we get plus xy, I'll combine that in the same column, plus y squared plus 2y. And then move to our last term, plus 2x plus 2y, again lining up the like terms, plus 4. And as you combine these, we get x squared, we get a total of 2xy, we get 4x, we get a total of our 1y squared, total of 4y, and then finally our constant 4. Okay. So either way, you'd write it in your standard form. From that, you can either use the patterns or you can just distribute.